And yet again we are going to solve a new problem, and this is an example of free undamped oscillation. And the problem is a cup of mass m is fixed to a vertical spring of a stiffness constant k, spring constant k. It is lowered from the equilibrium position by a distance a. Right. Cup ka mass tha, don't forget it. And then it is lowered from the equilibrium position by distance a. And the cup is released. Okay. And at the moment of passing the equilibrium position, a plasticine ball, oh no, yeah, चीनी मिट्टी का बॉल है ये. Plasticine ball of mass m. Yes, some inelastic collision. It will cause some inelastic collision. Plasticine ball of mass m, which has no initial velocity, thank God, sticks to it. Find the amplitude a1 of the system's oscillation after the impact. The acceleration of gravity is g, we know. So, what can we say about it? The amplitude of the ball is clear cut. The amplitude of the cup's oscillation is clear cut A. And immediately before the collision, it was passing through its equilibrium position. So its velocity will be maximum, and that will be equal to omega A, amplitude multiplied by omega. And I can see here that in this problem there is nothing but omega equal to under root k by m. So velocity of the cup just before the collision, because central event in this problem is collision, so I'm focusing on the situations before the collision and after the collision. So just before the collision, v is equal to amplitude multiplied by omega. And what about its velocity just after the collision? That can be determined from the law of conservation of linear momentum during the collision. And before collision, its velocity was mv, and after collision, this was an inelastic collision, I can remember, and so I can write here their velocity will be something u after the collision, so that we can write here u equals ma by m plus m under root k by m. This is now we need to find what was in the problem. Find the amplitude a1 of the system's oscillation after that impact. What is going to happen? Mechanical energy of the system will remain constant. And at this moment, it is passing through the equilibrium position, and I will take the equilibrium position of the system right now, as the datum where potential energy can be taken as 0, so that they will have kinetic energy only at this moment. I can make these assumptions. I'm free to take the datum anywhere I wish. So I would like to take it here at the equilibrium position where the collision just collision took place, and I'm going to take it as a datum for gravitational potential energy. So the total kinetic energy here will be half mv square, and that is half m plus m u square. And putting the values of u, I can get k ma square by 2 m plus m. So now I need to find out the amplitude of oscillation. So I have to think about the moment of its greatest deviation from the equilibrium position, and it can be taken anywhere, and I can take at the bottom. So spring, and there was equilibrium position, and we are here. This is equilibrium position, and the system is ready with this kinetic energy, the total mechanical energy at this moment. Datum is right here, and this is the position of maximum deviation from equilibrium position. And I could have taken it up during its upward motion or during its downward motion. I just chose one, and let's call this distance as b. Yeah, this distance as b. So that total mechanical energy can be written as gravitational thing will be from, in reference to this datum, we can write here minus m plus m gb plus kinetic energy of plus potential energy of a spring, because kinetic energy will become zero here. This is the extreme position where the body has come to rest. So the potential energy, I would like to write final potential energy minus initial potential energy, that was elastic potential energy, so half k mg by k was the initial stretch in the spring when it comes from natural length to equilibrium position, and plus b half kx square minus change in its potential energy is again half k, and it has got some initial potential energy that was mg by k square. So, and this will be equal to the total mechanical energy at the equilibrium position, that was this. And you need to solve it for b, and you will get finally get after solving, you will finally get in terms of b an equation like this: b square minus 2mg by k b minus ma square by m plus m equals 0. And you will get, since this equation is quadratic in b, so you will get two values of b, two roots of b, say b1 and b2, and amplitude of oscillation, then you will be able to write if b1 and b2 both qualifies as a positive length, then you should write the new amplitude of oscillation simply by b2 minus b1 by 2, and that will be your answer. and the answer I know in this case is ma square by m plus mg by k square, and you can solve it like this. Thank you very much for watching.